Hi, I'm Jack Hanna, and I work with some of the world's most interesting and exciting animals. Some are cute and cuddly, and some are scary and dangerous. If you really want to learn more about animals and how they behave, you need to learn about the world in which they live, their habitat. Stay tuned to learn about habitats on this episode of the NASA Y-Files, the case of the inhabitable habitat. Here we go.
Hey, you who me, yeah, you come see our clubhouse in a tree. We are kids on a mission to educate ourselves about the NASA vision. Come explore math and science, cause that's what makes our alliance. We are the Wi-Fi Club, we yearn to learn and want to see everything that we can be. So come join us on our journey. Don't you touch that dial, and welcome to the NASA Y-Files.
Join the Treehouse Detectives on their latest project. You can help by answering the following questions. Why is Mars called the Red Planet? What is a habitat? And what are the basic needs of plants? Don't forget, when you see this NASA Y-Files logo, the answer is near.
What are you doing here? I hope you're not thinking of going swimming in those clothes.
Forget about swimming. You've got to get back to the treehouse. We're starting a new project, and you're not going to believe what it is. Come on, let's go.
But I really wanted to catch some fish. I've been trying for several days, and I haven't caught any. I wonder if there's a problem with the water.
Forget about the fish. We're going to build a habitat for Mars.
How long have you been in the sun? Jacob, I think you need some rest.
I'm fine, but we better get back to the treehouse. Come on.
Okay, but I wonder what's wrong with the fish.
I'm Ted Toon, and Kids Science News Network is interrupting this broadcast for an exciting bulletin. The young astronauts are at it again, this time with a contest that's out of this world. For details, we go to our spaced-out correspondent, I Am Listening, who's live on... Is this right? She's live on Mars?
Yes, but how is my lipstick going to show if everything is red? I just don't... What? We're on? We're on! That's right, Ted, Mars. I'm here live on the Red Planet, an entirely new environment with new and exciting challenges. Perhaps the greatest challenge being simply to survive. Do you have what it takes to build a model of a Mars habitat? If so, visit the NASA Y-Files website for all the details and get to work. Be the first kid on your block to discover what life is really like on Mars. Back to you, Ted.
Yes. Well, that was I Am Listening on Mars. This is Ted Toon, back here on planet Earth. Signing off.
Awesome! Can you imagine living on the planet Mars for a year?
I don't know. It seems great. But don't you think living on another planet could be very difficult?
If I can live with my sister, then living on Mars should be really easy.
Hi, Jacob. Hi, Kaylee. Did you guys have any luck at the beach? I haven't caught a single fish for weeks. Something's definitely wrong, but I can't figure out what it is.
That seems strange.
What's in the box, Jacob?
I brought some stuff from home for our Mars model.
Have you heard about our latest project? Yeah, Jacob told me all about it. How are we going to build a habitat for Mars?
Check this out. This will be our recreation module. It'll contain a ping pong table, air hockey table, and a garage space for...
You guys are getting ahead of yourselves.
Do we even know we will need to live on Mars?
Remember what we learned in the invention contest? We need to do a lot of research and designs before we can actually build a model.
She's right. That's called the iterative process. So where should we start?
KSNN said there's a lot of information on the project on the NASA Y-Files website.
I'm on that website right now.
What's it say?
First, the habitat must meet the basic needs to sustain human life on Mars. And the model must be divided into 3 separate sections. Also, the habitat must utilize sunlight as a major source of energy. And experiments must be planned for both the trip and for Mars.
Wow, sounds complicated. So where do we begin?
We begin with the scientific method.
Or scientific inquiry. I know we use the scientific method to solve other mysteries,
But how are we going to use it to build a model?
It doesn't matter whether you're solving a mystery or building a model. The scientific method is a great tool to use.
I'm sure we can talk to a lot of experts at NASA about Mars and space.
And fish. Maybe we'll talk to someone who knows about fish habitats and they can explain why I haven't caught any lately. Great, let's go to the problem board. We know we need to build a habitat that can sustain life on Mars. What do we need to know?
We need to know what Mars is like.
Yeah. Is it hot or cold?
And is there anything there we can eat?
It's kind of like planning for a vacation.
I don't think that going to Mars is quite like a vacation, but you're right. We have to know a little bit about the place we're going.
So where do we start?
I'll bet NASA knows lots of information on Mars.
I'll check out the NASA Langley Research Center's website. They've done a lot of research on Mars.
Great. We should go to the library and check out some books on Mars.
I have some books on planets and solar systems at home. I might even have an encyclopedia in my book bag.
Can't be serious.
Well, you never know when you need an encyclopedia.
NASA had several unmanned missions to Mars. I'm sure they'll have a lot of experts.
With their help, this project will be easy.
Yep, here it is. It says here that the average temperature is minus 23 degrees Celsius.
I thought it would be hot. It only looks hot because of its red color. It's farther away from the sun than we are.
We'll have to make sure our habitat has a big heater.
One heavy-duty heater coming up.
Actually, the average is minus 23 degrees Celsius. The low is minus 140 degrees Celsius. The high is 20 degrees Celsius.
You were right, Catherine. There are a lot of articles about Mars on the NASA website.
Here's one about a Mars plane by Dr. Levine. He's my mom's friend. Maybe we can email him and see if he can help us. Print out the Get Up and Go sheet for us to take with us. You can go to the NASA Wi-Fi's website on the research rack and print out your own sheet.
I'd love to talk to Dr. Levine about Mars.
Great, let's get up and go.
Hi, are you Mr. Levine?
Yes, I am, and you must be the Treehouse Detectives. I understand you want to learn more about planet Mars.
That's right. We're designing a habitat that will sustain life on Mars.
So we figured we needed to learn more about the red planet.
Well, you've come to the right place. Mars is a very inhospitable planet, and you must be prepared.
What's it like on Mars?
Let's take a look. Mars is a very different planet than the Earth. No trees, no flowers, no animals. Mars is a very desolate planet.
Why do they call it the red planet?
The surface of Mars contains large amounts of rusty iron that give Mars its reddish color. In addition, strong winds blow surface material up in the atmosphere, giving the atmosphere a reddish-pink color.
Does Mars have land features, like Earth?
Yes, Mars has lowlands, mountainous highlands. Mars has the largest volcano in the solar system, and Mars has the longest canyon in the solar system.
I've seen the Grand Canyon here on Earth, and it was pretty big.
Oh, it's far bigger than the Grand Canyon. Marianas Valley on Mars is about 3,000 miles long, about the same distance as a trip from New York to Los Angeles.
What kind of atmosphere does Mars have?
The atmosphere of Mars is very thin, it's cold, and it's dry. The atmosphere of Mars is only about 1/200th the thickness of the Earth's atmosphere.
Is there oxygen like here on Earth?
No. In fact, the atmosphere of Mars is 95% carbon dioxide, 3% nitrogen, and 2% argon.
We'll definitely need to bring our own oxygen.
How do we know so much about Mars?
Over the last 30 years, NASA has sent a number of spacecraft to Mars to study the planet. Here at the NASA Langley Research Center, we're looking into the possibility of sending the first robotic airplane to Mars.
That would be so cool.
Would you like to see what our plane will look like flying through the atmosphere of Mars?
That would be great.
Check this out.
Wow.
Thanks, Dr. Levine.
You've given us a lot to consider about our habitat.
You're welcome. Anytime.
Hey guys, how was Dr. Levine?
He was great.
You wouldn't believe all the missions NASA has sent to Mars.
I'll enter the detail from the Get Up and Go sheet into the computer.
That's a good idea. Wait till you guys read about what we learned. I had no idea Mars was so different from Earth.
Not only was it much colder, but the atmosphere is almost all carbon dioxide.
They can't breathe any of it at all.
There is also no food or drinking water on the planet.
It doesn't sound very inviting.
It sounds like we have a lot of things to consider before we design our habitat.
First, we need to decide what we need to bring.
Exactly, and to do that, we have to know what makes a habitat. Bianca, Catherine, and I are going on vacation to Discovery Cove in Orlando, Florida. I'm sure they have lots of information on habitat.
I'll email them and see if we can meet with one of the experts on habitats while we're down there.
And Anthony and I can do some more research. I bet we'll do lots of research. And we'll start getting some materials together so we can design our habitat.
I bet the researcher there will help me figure out why the fish are missing from the bay. We better print out a couple of those get up and go sheets.
Wow, this park is really cool.
I can't believe there's so many different habitats.
I know. We've seen the stingray pool, the bird aviary, and the coral reefs.
Hi, kids. My name is Laura. You must be the Treehouse Detectives. How can I help you today?
Yes, we are. We need to learn more about habitats.
Well, you've come to the right place. Discovery Cove has over 7 habitats, and we have over 300 species represented here.
Wow, that's a lot of different habitats. What exactly is a habitat?
Well, a habitat is an environment that provides the basic necessities to sustain life. Things like food, water, and even shelter.
What are some different types of habitats?
Different habitats are things like our tropical reef habitat. We even have a stingray lagoon, but out in the wild, things like the desert, forests, and even ponds.
Okay, we know that habitats meet the basic needs, but is there anything else that makes them different?
Well, sure. The types of animals and plants that actually live within the habitat make all the difference in the world. You might consider animals that live in a tropical reef totally different than something that lives in a rainforest. But even within a rainforest, you're going to have different habitats like the canopy or even the floor of the forest. Different animals will live in different areas depending on what they need to eat, what types of predators live in the area, how they're capable of climbing or even flying.
We've noticed that there are no fish in the bay back home. Could it be because they've moved to a different habitat?
Yes, fish will move throughout their lifetime depending on their needs. They may move for feeding or even for their breeding behavior. I have a friend that works with signals of spring. He works with sea turtles and studies their migratory patterns. Maybe he could help you with your fish problem.
That would be great. Could you email us his name and number?
Sure, I could. And if you want to experience a really different habitat, you'll have to swim with the dolphins.
We can swim with the dolphins?
That's awesome.
Come on, I'll show you our dolphin cove.
That looks pretty good. What is it?
After we got your email about basic needs, we decided we better get back to the basics. So we were working on building 3 different modules to provide the basic needs of air, food, water, and shelter. But we're having some problems. Just doesn't seem to work to have the 3 modules separated. According to my calculations, we probably need 3 modules just to store enough food and water to survive.
We should call Dr. D. He'll be able to help. Besides, I wanted to talk to him about the fish problem, too.
Hello?
Hello, Dr. D. This is Bianca.
Hi, Bianca. How can I help you?
We were wondering if you could help us with our latest project. We're trying to build a habitat on Mars.
Sure, come on over. Right now I'm working on my terrarium. Maybe we can help each other.
Great. We'll be right over. Bye.
Bye-bye.
Hi, Dr. D.
Hi, guys.
Is that the terrarium that you mentioned on the phone?
Yes, it is. A terrarium is a clear container filled with small plants. Sometimes it's open to the atmosphere, but mine is going to be tightly closed. It's really tricky to maintain all the basic needs of plants after I close it up.
We learned about the needs of humans and animals. They include water, shelter, food, and air.
What are the basic needs of plants?
I'm sure they need water. And they need food.
That's right. The most basic food of plants is the carbon dioxide in the air.
And plants also need sunlight.
You bet. If my terrarium is going to be successful, it must meet all these needs. Hey, I understand you need some help in designing a model for a habitat for Mars.
We're having a little trouble getting started.
Well, the best place to get started is to understand your problem by gathering information.
Do you mean like the scientific method?
That's right. So what do you know about the atmosphere of Mars?
We know that it's mostly made up of carbon dioxide and hardly any oxygen.
That's right. And not only that, but the Martian atmosphere is much less dense than the Earth's atmosphere. So in addition, not having any oxygen to breathe, there's yet another difficulty.
What do you mean?
Let me show you with this vacuum pump. Here, touch this water. What does it feel like?
It's warm, but it's not very hot.
I'm going to put this water underneath the bell jar. And the vacuum pump's going to pull most of the air out of the bell jar. Let's see what happens.
Wow, the water's starting to boil. Does that mean it's hot?
Let's find out.
It's even cooler than before.
That's right. The water didn't boil because it was hotter. It turns out when the atmosphere is less dense, water will just boil at a much lower temperature. On Mars, you can have ice or water vapor, but any liquid water will simply boil away or freeze.
I guess our habitat had better have a denser atmosphere than Mars.
Thanks, Dr. D. Oh, and by the way, I'm concerned about why the fish are missing from my favorite fishing spot.
Maybe you should have the water tested. I also want to contact Ranger Cortez at Sandy Bottom Park. He'd be able to help you.
Thanks, Dr. D. Bye.
Bye-bye.
So what's up? Is Mars too harsh an environment for exploration? Will the Treehouse Detectives be able to take enough food to Mars? What happened to the fish in the bay? Find out in the next exciting chapter of The Case of the Inhabitable Habitat.
In part 2 of The Case of the Inhabitable Habitat, you'll discover what is a food web, what is transpiration, and why does NASA want students to grow plants?
Hello, Ranger Cortez.
Hi, Kaylee. Dr. D said you might be coming over for a visit today. What can I help you out with?
I'm concerned about the fish in the bay. No one has caught any for a long time. I'm trying to figure out what's happened to them.
Well, what do you think happened to them?
I think it might be because they don't have enough food to eat.
That's possible. Have you checked to see if anything happened to disrupt the food web?
What's a food web?
Organisms that live together in an area are called a community. Members of the community depend on each other for survival. This dependence is called the food web.
How do they depend on each other?
In a typical community, you'll find producers, consumers, and decomposers. Plants and algae are producers. They take the energy from light and use that to convert carbon dioxide, water, and minerals into food. This process is called photosynthesis.
What are consumers?
Organisms that eat other organisms are called consumers. There are 3 different kinds of consumers. Do you know what they are?
I think that one is a herbivore. They eat plants. And one is a carnivore. They eat other animals.
That's right. And an omnivore is a consumer that eats both plants and animals.
I guess that makes me an omnivore.
You can see how they all depend on each other. If plants didn't exist, the herbivores would have nothing to eat, and they would not survive.
And if the herbivores didn't survive, then the carnivores wouldn't have anything to eat.
That's right. You catch on quick.
What are decomposers?
In order for a community to be successful, there must be a way to return the minerals and other basic ingredients back to the producers. Decomposers do this.
How do they do that?
Decomposers, bacteria and fungi, feed on dead producers and consumers and convert them back to the basic materials needed by producers to grow and reproduce.
It's a cycle.
That's correct. Now what you might want to do is take a look at the ocean and see if there's anything that happened to disrupt the cycle of the food web.
That's a great idea, thanks.
Oh, by the way, would you mind taking a couple of plants to Dr. D for me? They're for his terrarium.
Sure, no problem.
Great.
Hey, Dr. D, look what I brought you.
Terrific. Looks like you brought something from my terrarium.
Yeah, Ranger Cortez from Sandy Bottom Park said you would like them.
Thank you. My terrarium is coming along pretty good. I'm being very careful to only put plants in that only require the same conditions.
Can you tell us more about how a terrarium works?
Sure, my sealed terrarium must be self-sufficient. The only thing that can come into the terrarium is light.
We already learned that light is a basic need of plants.
Water is recycled in a terrarium. Plants give off water, which collects on the plastic, runs down the side into the soil where it's collected by the roots and recycled.
Wow, that's pretty neat.
I already talked about how the plants basically produce carbon dioxide. Plants consume carbon dioxide and produce oxygen. But what replaces the carbon dioxide so the plants don't die?
Well, animals breathe in oxygen and breathe out carbon dioxide, but obviously there aren't any animals in there.
That's true, but there are decomposers in the soil like bacteria and fungi. They also consume carbon dioxide and produce oxygen. They also break down dead materials to produce the nutrients that the plants need.
It looks like everything gets recycled.
Turns out that plants use some oxygen to produce the energy they need and give off carbon dioxide in the process. This is called respiration. Fortunately, plants produce much more oxygen than they consume.
I'm glad about that.
There's a lot going on in that terrarium.
It would be great if we could make our Mars habitat as self-sufficient as your terrarium.
Yeah, just add sunlight.
We've got to get going. We've got a lot of work to do.
Yeah.
Bye, Dr. D.
Bye.
I don't think this is working.
Can't take enough food with us.
We need to find a food source, a food web.
Ranger Cortez did say that the food web is important. But how are we going to create a food web on Mars? Maybe there's a problem with the food web in the bay. Maybe pollution upset it. That should be my hypothesis. If pollution upset the food web in the bay, then the fish would leave.
People create habitats all the time, like Discovery Cove or even Dr. D's terrarium. They all have food webs.
That's true. All we really need to do is find a way to create food in our habitat.
Maybe we can grow food on Mars.
Yeah, and plants create oxygen. We need air.
Lots of it.
Guys, we don't even know if plants can grow in space. We need to do some more research.
The problem board.
Okay. We know that all plants and animals have basic needs, and that they all rely on the food web. We also know that plants play a major part in the food web, so we need to know, can we grow plants in space?
Anthony can check the internet.
I found something that might help us. Mr. John Gruner at the Johnson Space Center is working with plants at the International Space Station. Let's dial him up and ask him about growing plants in space.
Hi kids, I'm Mr. Gruner. How can I help you?
Hi, Mr. Gruner. We're the Treehouse Detectives, and we're trying to design a Martian habitat.
We realize that we have to grow our own food on Mars.
Yeah, because we don't want to go hungry. And we need to know if plants grow differently in space than they do here on Earth.
Well, sort of. But plants still need the basics like light, air, water, nutrients, and a nice temperature and humidity.
We know that Mars is extremely cold.
And that it doesn't have the same atmosphere as Earth.
Does that mean that we can't grow anything on Mars?
No, it just means you'd have to grow them indoors in a controlled environment.
How do you do that?
Well, here at NASA, we design plant growth chambers or systems to meet the plant's basic needs. Kind of like this one here.
Do you have to use special seeds to make the plants grow in space?
No, we use the same seeds as we do here on Earth. However, we do conduct experiments and collect data to see what effect low gravity and increased radiation has on the way plants produce seeds.
Why is that important?
We want to make sure that plants can reproduce in space. This will help astronauts who live there for a long time.
Can the seeds produced on Mars grow here on Earth?
Yes, and they're able to germinate and grow into new plants just fine.
Do you only use plants in space for food?
No, we also hope to use plants to produce oxygen and water.
That is so cool.
During a process called photosynthesis, plants take in carbon dioxide and produce oxygen.
We breathe oxygen and exhale carbon dioxide.
Exactly. So you see, plants and people can live very well together, trading gases.
Okay, I understand that, but how do they produce water?
Through a process called transpiration.
What's transpiration?
Well, when a plant transpires, it releases water through tiny holes called pores that are mostly found in the leaves. And then the water evaporates into the atmosphere and we can collect it and turn it back into liquid water on a cold surface.
Oh, you mean just like the water droplets on the outside of my glass of ice water?
That's right. It's called condensation.
I guess it is important to be able to produce water and oxygen since it takes a long time to get to Mars.
You bet it is. It would be very expensive to send space vehicles to resupply the habitat. Therefore, it is very important for the habitat to be as self-sufficient as possible.
What kind of plants are you growing in your lab?
We are currently experimenting with grains like wheat and rice, legumes like peas and peanuts, potatoes, fruits, and salad crops.
I love salads.
That's good, because right now there are no plants to produce any meat.
I don't like just vegetables.
Well, don't get too discouraged. Meat will still be available in packaged form, but in small quantities. However, there are still lots of good foods you can make with fruits and vegetables.
Like what?
Well, like peanut butter from peanuts, jelly from strawberries, tortillas from wheat, and potato chips from potatoes. You could even make tomato sauce from tomatoes for pizza or spaghetti.
Now you're talking. That's my kind of meal.
And just like here on Earth, the most important thing is to eat a balanced and nutritious diet.
That's true. My mom always tells me that.
Would you like to see us harvest some carrots from our chambers?
Yes.
All right.
Thanks, Mr.
Good luck with your project, kids.
I can't believe they actually grow plants in space for food.
And oxygen.
We definitely need to grow plants in our habitat.
I read on the internet that some experiments on the ISS are done by kids. We should check it out and see if anybody on the NASA Wi-Fi's Kids Club grew control plants.
Maybe we could grow our own plants for the model.
They would have to be pretty small to fit in our model.
Mrs. Schwartz's class at Kent Mill Elementary School in Silver Springs, Maryland participated. Check it out.
Hi, I'm Bowie. I am in Ms. Schwartz's 4th grade class at Kent Mill Elementary School in Silver Spring, Maryland.
Hi, we read on the internet that you're participating in a NASA project with space seeds.
Yes, we are growing Arabidopsis plants.
What are Arabidopsis plants?
They are more commonly known as mustard weed. It has a life cycle of 6 weeks from seed to seed. It is easy to grow in small places. Also, it produces a lot of seeds. That makes it a great test plant to be grown in space.
How do you get space seeds?
We participate in a NASA experiment through a company called Space Explorers, Inc. They get the seeds from NASA and distribute to teachers who have signed up for the program.
Why does NASA want children to grow the space seeds on Earth?
Whenever you are doing an experiment, you have to have a control group. We grow the plants as the control group for the experiment on the International Space Station.
We learned about controls from the scientific method.
We measure the plants as they grow and keep accurate records. This gives NASA a reference point of normal growth and reproduction to compare with the plants grown on the International Space Station.
Why is that important?
Scientists need to make sure that the plants are growing and producing just like they do on Earth.
Is there anything else that the plants do for the astronauts in space?
Yes, they create a bioregenerative life support system.
What is that?
It's a system that uses plants rather than machines. The plants release oxygen, help recycle drinking water, and create water vapor through transpiration.
Just like Mr. Gruner mentioned.
We definitely need a bioregenerative system in our habitat.
Thanks for helping us.
You're welcome. And good luck on your project.
That is so cool.
So we know we can grow plants as a source of food and oxygen.
NASA sure is doing a lot of research on living and working in space.
My mom and I are going down to Johnson Space Center in Houston. Maybe while I'm down there, I can do some more research.
I've never been to Johnson. I'd like to check it out.
Okay, I'll call my mom and see if you can go with us.
So what's up? Will living on Mars require any special training? What will Bianca and Anthony learn at Johnson Space Center? Did pollution kill all the fish in the bay? Don't leave the planet. Stick around for the next segment of the Case of the Inhabitable Habitat.
Pay close close attention and you'll learn the following. What is the KC-135 used for? What is neutral buoyancy? And what does a spacesuit protect astronauts from?
Hey guys.
Hey, RJ.
What in the world is that?
You mean what in the Mars is that? Actually, it's a badminton set.
This is pretty heavy. How are you going to play badminton with this?
Well, you see, there's less gravity on Mars, so the racket needs to be heavier. This is part of the experiments we're going to be doing on Mars.
Well, we could be the first ones to play badminton on Mars.
Exactly.
Oh, how's the fish problem going?
It's good. I heard back from the EPA. That's the Environmental Protection Agency. They said that there's no pollution in the water and that it's the normal temperature for this time of year. So I'm still confused.
Don't worry, I'm sure you'll figure it out.
Hey guys, KSNN is on.
Well, ladies and gentlemen, I've been told that I Am Listening was not actually on Mars yesterday, but was participating in a simulation of living on Mars. For this experiment, she has now been sealed in a simulated Martian habitat where she will experience what it will be like for astronauts to live on another world. We join her now for a live report. I Am, how's it going?
Ted, you've got to help me get out of here. I'm down to a packet of Tang and 2 stalks of celery. I cannot take this anymore.
But you've only been in there for 15 minutes, and you had enough food for a week.
Ted, help me, Ted!
There you have it, folks. It looks like it's going to take more effort than locking a reporter in a closet to figure out how to live on Mars. I'm Ted Toon for KSNN.
You know, living in space would be quite an adjustment.
I read that astronauts had to train to go to space.
I wonder if we'd have to train to live on Mars.
Of course. You don't just go 7 to 8 million kilometers without training.
I wonder how you train.
Looks like it's time for a trip to the problem board.
We know that we have to build a habitat on Mars.
And we know that plants and animals have basic needs.
We also know that there are lots of different habitats, but they're all basically the same.
Also, the food web is important to all habitats, and plants can be used as a food source in space.
We need to know how people train to live in space for a long time.
Where should we go?
I saw earlier on the computer that Dr. Textbook has a show about how people learn to live in space.
Let's check it out.
Here's Dr. Textbook with an exciting look into the history of living in space.
Hello! Well, today we're going to learn about one of man's greatest challenges, living in space! For centuries, people have adjusted to different living conditions, but none so drastic as going from the surface of our planet into outer space! Leaving the pull of Earth's gravitational force requires training and discipline. NASA astronauts use sophisticated simulators and machines to prepare themselves to leave Earth's gravity.
You experience the same feeling while riding on a roller coaster or even while spinning on a merry-go-round.
Once you've entered space, however, everything changes. You've left Earth's gravitational force behind you, and you've now entered the microgravity zone. In a microgravity environment, you must be able to work right side up
Or upside down. Doing this on Earth can be slightly uncomfortable, but in space there is no up or down. It feels the same no matter which way you hang.
Also in microgravity, simple tasks like eating are very challenging. In the early days of spaceflight, astronauts relied on orange powdered drink mix and freeze-dried fruit. Now they enjoy a variety of full-course meals. Of course, life in space does have its benefits. On Earth, these weights are difficult to lift, but if I let go of them in space, they simply stay put. Ah! Not a very good idea.
Poor Dr. Textbook. He didn't seem to adapt.
I guess the fish haven't been able to adapt very well either, or they'd still be swimming in the bay. Maybe that should be my new hypothesis. If the fish can't adapt to their new environment, then they will leave the bay. But why wouldn't they be able to adapt? I guess I need to do some more research.
Adapting seems like a difficult process.
Let's go ask Dr. D. He could probably tell us.
Yeah.
Good idea.
Come on.
Hi, Dr. D.
Oh, hi, guys. How's your project going?
It's going well, but we still need to learn more about training and adapting to living in space.
I'll give you an example about adapting here on Earth. When astronomers go to work at the observatories on top of Mauna Kea in Hawaii, which is almost 14,000 feet above sea level, they have to adapt to a new environment.
But if it's on Earth, why do they have to adapt?
At very high elevation, there's much less oxygen than here at sea level. In order to adapt, these astronomers go part way up the mountain to about 9,000 feet, spend about 24 hours there at this elevation where the conditions are not quite as extreme.
What happens if they don't?
These astronomers might get altitude sickness. If they take this time to let their bodies get used to less oxygen, they might not suffer such symptoms as headaches or severe tiredness when they get to the top of the mountain.
That's really interesting.
Let's play a little game to see if you can adapt to a new environment.
Are we gonna climb a mountain?
No, I'm going to put you in a mirror image environment. What you have to do is trace this star while looking in the mirror. Just stay between the lines.
This looks really easy. I want to go first.
Go ahead and give it a try.
Wow, I can't move my hand. This is really strange.
I bet I could do much better.
It's harder than it looks. All right, let me try it again.
All right, go ahead, another star.
It's easier this time. It's still hard, but I'm able to do it better this time.
Guess that you're learning how to adapt to this new environment. You might want to learn more about how people train to live in space.
Where should we go?
I don't know, you might check out the NASA website.
If anyone knows, they should.
Thanks, Dr. D. Bye.
Bye.
Jacob, what are you doing?
I'm testing my new Mars pogo stick.
I don't think your pogo stick's gonna work very well on Mars.
Why not?
Remember the case of the challenging flight? We learned about Newton's first law.
That's right. An object in motion stays in motion until a force acts upon it.
So you see, Jacob, if you jumped on your pogo stick in Mars, you'd end up in space.
Not necessarily. I did a little research. I found out that the Apollo astronauts jumped all over the moon, and the moon has 1/6 the gravity of Earth.
That's less than Mars, which is 1/3.
But the Apollo astronauts had suits that weighed 350 pounds. That's why they didn't jump very high.
Well, that means that on the moon, it would weigh about 58 pounds, or 116 on Mars.
Wow, he's good at math.
So I might be able to use my pogo stick.
Well, you could, but I wouldn't unless I did a lot more research. Hey guys, I just got an email from Mr. Del Rosso. He can tell us how astronauts train to live in space.
Hi, I'm Dom Del Rosso, test director with NASA's Reduced Gravity Airplane. How can I help you?
We need to learn more about astronauts and how they live and work in space.
Well, they train in many different ways. One of the ways is aboard our KC-135, the Weightless Wonder.
Why do you call it the Weightless Wonder?
The KC-135 is an airplane we can use to simulate the free fall of zero gravity so the astronauts can experience weightlessness.
How do you simulate weightlessness in an airplane?
Well, we fly a series of huge arcs in the sky we call parabolas. It's kind of like riding a giant roller coaster in the sky.
I learned about parabolas in math, and I love roller coasters.
Well, then you would love the KC-135. We start at an altitude of about 24,000 feet and climb to make an arc. When the plane reaches the top of the arc at about 33,000 feet, it dives back towards the Earth. Anyone inside the airplane is also falling at the same rate that we're diving. This causes the people to float around inside.
That's really cool. Do they float for very long?
Not really, only for about 20 or 25 seconds in zero G. However, we can change the parabola to simulate either the gravity of Moon or Mars, and they last a little bit longer.
So how does this help the astronauts to train for space?
Well, it gives the astronauts a chance to see how their bodies will react and adapt to weightlessness, as well as give them a chance to practice with their experiments before they fly. We can also use it to verify and help design new hardware for the astronauts to use later on.
I get sick when I ride roller coasters. Do people ever get sick on the KC-135?
Well, yes, occasionally an astronaut will get sick, and that's why sometimes people call it the vomit comet, but it doesn't happen all that often.
Thanks, Mr. Del Rosso. This really helped.
You're welcome, and good luck on your project.
Goodbye, Mr. Del Rosso.
Wow. It'd be pretty cool to float in space. Unless you got sick.
You'd have to have a pretty strong stomach to be an astronaut.
You have to have a pretty strong stomach to train.
Speaking of training, I just got an email from Bianca and Anthony down at Johnson Space Center. They're going to talk to Mr. Utley at the Neutral Buoyancy Laboratory. I think that's where they train for spacewalks.
Well, the Neutral Buoyancy Laboratory sounds a lot easier than the vomit comment.
I hope they don't get sick.
I never thought a laboratory would have a swimming pool.
Me either. I wonder what they do here.
I'm glad you asked. You two must be the Treehouse Detectives.
Yes, we are.
Well, my name is Mr. Utley, and this is the Neutral Buoyancy Laboratory, or NBL. We use this tank to simulate a weightless environment just like you'd see in space.
It sure is big. Just how big is it?
The NBL is 202 feet long, it's 102 feet wide, and 40 feet deep. That means it holds just over 6.2 million gallons of water. That's as big as 12 Olympic-sized swimming pools all put together.
Wow, that is big. Why do you need such a big tank? I mean, laboratory.
Well, the International Space Station components are really big, so we need to have an environment that was big enough to be able to have astronauts practice putting all the components together.
How do the astronauts train in the NBL?
Well, instructors coach the astronauts on tasks and techniques in spacewalks that they're going to have to do while living and working in orbit.
Spacewalks? Why would they need to walk in space?
Well, sometimes astronauts have to go outside of their space home to do such things as assemble the space station or even fix the Hubble Space Telescope.
Is there anything else they do in the NBL?
But yes, as a part of spacewalk training, they train on tasks like connecting power supplies, deploying radiators, deploying solar arrays, or even changing batteries.
Changing batteries? That doesn't sound very hard.
Why do you have to train for such easy jobs?
It may sound easy, but working in space is very challenging. There is no up or down, and so objects may not be in the same orientation they were in when they were training here in the NBL.
At least all the heavy stuff doesn't weigh as much as it does on Earth.
Well, actually, even though it's weightless in orbit, objects still have their mass. So you have to be very careful about moving a large object quickly because it will build up momentum. So astronauts have to train to be able to move things very slowly and deliberately.
This is a lot more complex than we thought.
Why do you use water?
We create a weightless environment by using the principle of neutral buoyancy.
What is neutral buoyancy?
Well, neutral buoyancy is when an object has the same tendency to float as it does to sink. And that just hovers in the water. And that is the same property as being weightless on orbit. So you can take a 190-pound astronaut, put them into a 200-pound spacesuit, pressurize the suit, and then add weights to the chest, back, and arms and legs just so that they're hovering around in the water. And that gives them the same reactive forces that they would have in orbit. So when you push yourself away from something, your body is going to continue to float away from it.
If the suit weighs 200 pounds, how do you get him out of the pool?
Actually, we're taking the astronauts out of the water right now.
Wow, those suits are awesome.
If you really want to know more about spacesuits, you should talk to Dr. Ross here at Johnson Space Center.
That would be great.
I'll give her a call and let her know you're coming.
Thanks, Mr. Utley.
Bye.
Hi, Miss Ross. I'm Bianca, and this is Anthony.
Hi, it's nice to meet you both. I understand from Mr. Utley that you want to learn more about the spacesuits that astronauts wear.
Wow, do astronauts really have to wear all this stuff?
Yes, they do. The spacesuit protects the astronauts from the extreme environment of space.
We know they need a spacesuit for oxygen, but what else does it protect them from?
It protects them from things like extreme temperatures, very small meteoroids, orbital debris, and radiation.
Wow, I didn't know space is so dangerous.
The spacesuit looks big.
It is big, and when an astronaut wears it, it inflates like a balloon to make it even larger.
Why does it inflate?
In space, there's no air pressure. And without air pressure, the astronaut's blood would boil.
That doesn't sound good.
No, it's not. So the spacesuit provides the air pressure the body needs to keep that from happening.
What are these?
These are the astronaut's long johns. They keep the astronaut cool while he or she works in space.
How does it do that?
There are little tubes woven into the long johns. Water flows through the tubes, keeping the astronauts cool.
There's some days I wish I had one of these.
Is that what I think it is?
Yes, it is. It's called a MAG, for maximum absorbency garment.
Do astronauts really have to wear that?
Yes, spacewalks can last up to 8 hours, and that's a long time to go without a bathroom break.
That's for sure. I couldn't go that long.
Neither can the astronauts, and they are working with billions of dollars of equipment They need to be able to concentrate in order to do their job correctly.
And you can't concentrate if you have to go to the bathroom.
Do you make these spacesuits, Miss Ross?
No, NASA hires a company to actually make the spacesuits. My primary job is to test and evaluate the suits so that I can design better spacesuits.
We learned all about that from our invention contest. It's called the iterative process.
It sounds like you've tested, evaluated data, and redesigned yourselves.
Do astronauts have to wear different suits for different jobs?
Sometimes. For example, Joe Cosmo and I worked with a company called ILC to build a better spacesuit glove.
Why did they need a better glove?
To build Space Station. The glove was a Phase 6, and I made sure it was ready to use in space.
Did it really work?
Yes, it did. The glove was used on the first American Space Station construction mission, STS-88.
That is so cool to know that you actually helped the astronauts build the space station.
I might do that someday.
Yes, you might. Keep up the hard work.
Thanks, Miss Ross. We learned a lot.
You're welcome, and good luck on your Martian habitats.
Thanks. Bye.
Bye.
So what's up? Is the treehouse getting a little messy? Did the fish migrate from the bay? Stick around and get all the facts in the final segment of The Case of the Inhabitable Habitat.
In the conclusion of The Case of the Inhabitable Habitat, you'll be asked, how are space trash cans different? How can space trash be dangerous? And what is migration?
We only have one more module to go.
The research module connects with the greenhouse.
This is really cool. I think I could live there. For a while anyway. It's almost as nice as the ISS model we saw in Houston.
We did a good job, guys.
We did. I wonder what kind of experiments we'll do in our research module.
Well, I've decided to focus on recreation in space. I think we should look into badminton on Mars.
Or pogo stick as a possible transportation.
But first we need to experiment on how to get rid of all this trash. I guess it has gotten a little messy in here. I wonder what they do with trash in space.
I don't think they have garbage trucks on Mars.
I bet Miss Ross knows someone who could help us. I'll contact her and see who we should call.
And while you do that, we need to get rid of all this trash.
Make sure you put the paper and plastic into the recycling bin. Wow, this looks much better.
I never thought building a model would create so much trash.
I hope it doesn't get that bad on the ISS.
Guys, look, I found someone who can help us with trash in space.
Hi, I'm Lisa Polanski, and I work on the International Space Station program at the Johnson Space Center. What can I do for you today?
We were wondering how you take out the trash in space.
On the space station, the astronauts have trash cans like we do on Earth, except they have a few differences.
What kind of differences?
When you're in a weightless environment, the trash has a tendency to float out of the cans. So we have special openings to keep it inside, and this way it doesn't bother the astronauts.
Trash is bad enough sitting on the ground. I wouldn't want it flying around everywhere.
Actually, the astronauts attach the can to the wall so it doesn't float away.
At home, I use the 3 R's: reduce, reuse, and recycle. Do astronauts use these in space?
Actually, there's not a whole lot to recycle on the International Space Station. We try to reduce the amount of items that become trash on orbit before they go up.
How do you do that?
One of the ways is by using more efficient packing material. We also reuse the clothing items like the shorts and the pants.
If you did have any trash, couldn't you just launch it into space?
One of the reasons we don't launch trash into space is because it becomes space trash, and that can be very dangerous.
How can space trash be dangerous?
Any trash injected into space travels at a high rate of speed, and at high speeds, even the smallest piece can do damage to the vehicle. A piece that is 10 centimeters long can cause as much damage as 25 sticks of dynamite.
25 sticks of dynamite? That's scary.
What do you do with the trash cans when they're full?
When the cans are full, we put it in the Russian unmanned vehicle called Progress. The Progress undocks from the International Space Station and burns up in Earth's atmosphere. We also use the space shuttle to return hardware that is reusable.
Wow, that's one way to recycle and reuse.
I didn't know a space shuttle could carry trash.
That's a lot better than having trash fly all through space.
That's exactly right.
Thanks for your help, Miss Polanski.
My pleasure, kids. Anytime.
So they do recycle in space.
So that means that we definitely have to reuse, reduce, and recycle in our habitat.
It's always a good idea to use the 3 R's.
Okay, let's get the camera so we can start working on our presentation.
Okay, first let's take a look at the living module.
Who's going to be our narrator? Come on, Kaylee. Don't you want to be in the presentation?
Yes, but I finally got an email back from Mr. Glenn Schuster of Signals of Spring. After doing a little research, I figured out that my hypothesis was wrong. I think Signals of Spring can help me come up with a new hypothesis.
What is Signals of Spring?
Signals of Spring is a project where students use data from NASA and NOAA to track migratory patterns of loggerhead turtles.
Now, I know what NASA is, but what is NOAA?
It's the National Oceanic and Atmospheric Administration. They're an environmental agency that collects and analyze data to predict changes in weather.
How are they going to help you?
I asked Mr. Schuster if fish migrated, and maybe that's the reason all the fish are gone. I think I finally have the answer. My new hypothesis is, if the fish have migrated, then there will be no fish in the bay.
What did he say?
He said I should contact Burbank Middle School. Mrs. Stewart's class is helping Signals of Spring track migration patterns of turtles.
That sounds great. Let's call them up.
Okay.
Hi, my name is Jacqueline Dang, and I'm in Ms. Stewart's class at Burbank Middle School in Houston, Texas.
Hi, I'm Kaylee, and we're the Treehouse Detectives. We think that the fish in the bay at home have migrated.
We definitely can tell you about migration, especially loggerhead turtle migration.
What is migration?
Migration is movement of animals. Signals of Springs helps us to use NASA real-time satellite imagery and maps to understand the migratory patterns of turtles.
Why do turtles migrate?
They usually migrate when the temperature changes, mostly toward the warmer weather.
Why do they move towards warmer weather?
Their food also migrates, so they follow the food.
How many turtles are you tracking?
Just one. Our turtle Marianne has a sensor glued to her back that sends NASA real-time data showing her location. The data is put on a website, and we plot the coordinates each week on our map.
Where is she now?
Right now, she's moving south at 35.4 north and 75.4 west, but when we started, she was off the coast of Virginia.
Cool. That's right near where we live.
Do turtles always migrate in the same way?
No, but they follow similar patterns each year.
Can a change in the environment cause a difference in migration patterns?
I think so, but you might want to check with the Virginia Marine Science Museum. They helped us a lot with our project.
That's a great idea. Thanks for all your help.
You're welcome. Good luck with your project.
I still don't know what happened to make the fish disappear. I better email the Virginia Marine Science Museum. Maybe they can help.
Good idea. And after that, you can help us with our presentation. Hi, Dr. D.
Welcome, Mars Explorers.
I see you finished your terrarium.
Yes, I'm really pleased with it. I think the terrarium is very close to being in equilibrium.
What's an equilibrium?
It means that everything is in balance. For example, in a balanced system, the amount of carbon dioxide consumed by the plants is equal to the carbon dioxide produced by everything else. My completed, sealed-off terrarium is a self-sufficient system.
That's great, Dr. D. We think we found the solution to our Mars habitat problem.
We first had to learn a lot about the Mars environment.
Yes, we learned that it's a pretty harsh environment. Cold, with a sparse atmosphere, and hardly any oxygen. That meant that our habitat had to be entirely self-contained.
Except for sunlight. That's a major source of energy.
Don't forget the gravity on Mars is only 1/3 as strong as that on Earth.
And we had to watch out for windstorms and meteors.
Since there's almost no oxygen on Mars, we decided we had better have lots of plants. They not only provide us with food, but also oxygen.
That's right. We had to meet the basic needs of the astronauts: food, water, shelter, and oxygen.
And we checked into alien environments and how plants can grow in them.
I learned that I need to acquire a taste for vegetables since there won't be any meat.
One of our modules was a trash management facility. There are a lot more than the 4 basic needs that need to be met in our habitat.
With our module, we also noticed that we had to take into account the adaptations the astronauts will have to make to live on Mars.
That's great. Haley, have you found any more information about your fish problem?
I talked to Mrs. Stewart's class, and they said that migratory patterns are usually consistent, so I don't think the fish have migrated.
Probably correct. Otherwise, fish would be missing every year.
They suggested I talk to the Virginia Marine Science Museum, and they said there had been an algal bloom in the bay back home. But I'm not sure what that is.
Well, let's do an internet search.
Okay, let's pull up a search engine.
Type in the words algal and bloom.
Here's a site that says harmful algae page.
Okay, click on it and see what they have to say.
How does an algal bloom make all the fish disappear?
It says the algae use the nutrients to quickly multiply.
It also says that some algae are toxic to fish. That means that the fish die. They can last up to a few days, and in some cases over a year.
I hope it doesn't last that long.
Me too. Guys, we better get back to the treehouse if we want to see our presentation on KSNN.
I'm proud of you guys and can't wait to see the presentation. I got a present for you. Here's a terrarium for your treehouse. Try to give it lots of indirect sunlight.
Thanks, Dr. D.
Bye.
Bye-bye.
Bye.
Well, that was certainly a nice-looking Martian habitat, but I don't think the judges will approve of the complete lack of bathrooms.
No, I don't think so, Ted.
And next up, the Treehouse Detectives, always a strong contender, with their Martian habitat. Here's Bianca with a live report.
Our habitat has 3 modules: a laboratory for working and conducting experiments, a living module for eating and sleeping, and finally a greenhouse for all our food, water, and oxygen. And yes, there's even a bathroom.
These kids have really done their research, Ted.
Right you are, I am. That habitat looks so cool, I'll bet they can't wait to move in. Care to join them, I am?
Never in a million years, Ted.
That's great, I am. And we'll be back with more of the Young Astronauts Parade of Martian Habitats.
Right you are, Ted.
Hey, Jacob, caught anything?
I think the algal bloom must still be out there. I haven't caught a thing.
Don't think so.
Well, mine must have just gotten away.
Here, let me see.
Look forward to even more exciting mysteries next season when the NASA Y-Files becomes the NASA Sci-Files.